We implemented the tools coming from COIN IP, but together with a legacy platform and also with some new development inside of our pilot to support better decision and cooperation on the level of farming sector. Why COIN IP and why these tools are so important for agriculture? Agriculture is a sector which is under big pressure of different influences, regulation, and businesses, and it is very important to have the access to information, and also there is required from many suppliers, customers, but also administration exchange of information. So farm management is something where is required interchange of information, and from this reason it's also very important interoperability. You have to consider that there exist a lot of different applications which has to farm use, and there is a lot of organization where farmer has to share the information. Unfortunately, currently, any organization, for example, food industry, Ministry of Agriculture, subsidies control, are using different systems, and there is a big problem for farmer to exchange information between his farm management system and this other external system. So you can see on this image some examples of communication. Of course, they are coming not only information from different organization, but could be also information from environment about weather, for example, rain, but also could be important some information from other farmers. On the farm level, for any decision is very important information flow. We can recognize three level of information. One are macro level on information. It could be also called external information, and this information are, for example, about weather, about prices on the market, about subsidy regulation, etc. So this information are very important for farming decision. Second part of information could be called farm level, and it is, for example, accounting system which describe overall situation of the farm. And then there is also micro level, or we can speak about field level, where are collected detailed information about every field, or if you are using precision farming, not only about every field, but also about every part of the field. So you can have a lot of information inside of every field. And for decision, you need to be able to put all this information together and to provide some intensive exchange of information. For example, if you would like to decide about fertilization, you don't need to have only information about the nutrients in the soil, which are on the micro level, but it could be also important information about weather, because to apply fertilizer in not right time could in principle remove all matters out from the source. So you need to be able to combine this information from all three levels to be able taking decision. Other important aspect why COIN is so important for us is collaboration. We have to consider that farmers are mainly micro enterprises, could be family farm where only few people are in one farm, or SME in better cases where we have some industrial farms where more people are working. But till now, all these farms are only SME. On other side, our investment in farming sector is very high. It is not only investment to the land or to the buildings, but also to machinery. And in many cases, this machinery is not used for all season, and there could be or is done some investment which is only necessary for some small part of season. So the idea is to thinking about the new concept of the farming, and as we are discussing in ICT, the model sensors as services. We can speak in a farming sector about something what we can call machinery as services or also infrastructure as a services. So also from this point, the collaborative tools of COIN are important for farming sector. As I already mentioned at the beginning, the platform Open Agriculture Services is integration of legacy platform mainly based on previous development of pre-farm advisory services, COIN integrated project components, MDIS and CCMS, and own development which was provided inside of COIN integrated project. It is mainly the module for optimization or forecasting of agriculture production. All are now included as a part of COIN Wirelessinfo CZ portal, and we have also considered one other aspect which is very important for farmers, and it is trust of information, because farmers are willing to share information or to put information on the cloud only in the case when they are sure that only people who they allow to share information will use this information. For example, farmers are very often afraid that the food industry will have access to all internal information of the farm, because food sector is much stronger than farmers, and it could be a big disadvantage for farmers. So also the trust of information is very important for such type of application. At the beginning, I mentioned the importance of interoperability and collaboration for farming sector. During our pilot in the COIN project, we implemented two services or two business use cases. First is tactical planning, and second is search for machinery, or we call this also machinery leasing. Both type of services are included as one part of two parts of a portal, and we can see on this portal three layers. The down layer are databases and services layer, which guarantee access to the databases and the possibility to display or work discovery data. The second level are portlets, which are used, or eventually iframes, which are used for application running inside of LiveRay interface, and the top level is LiveRay. About architecture of tactical planning. As we mentioned, there could be used different resources of information for preparing of tactical plan. On one side, we can use the information coming from pre-farm, and here we have to consider that in our system we have now 400,000 hectares from approximately 160 farms. In the number of farms, it's not so big, but in the number of hectares, it is almost 7% of all Czech arable land is now inside of our databases. Other data could come from sensors or some other mapping data could be zones for subsidies and other. This is the part of graphical data. This data could be discover, visualize, or compose using the tools which are which was developed as legacy platform in past and was integrated. On other side, we can use some external information. I mentioned that external information are very important for the decision of the farm, this external information. Now, in our pilot, we use mainly some databases coming from Czech Statistical Office or Eurostat, because there are data about the production costs for many years, and this data help us to prepare the recommendation. With MDIS, we are able to transform this data, all this data into interoperable form, which is then used for optimization. The last step of this process is to visualization of the data. We can visualize data in the form of tables, but for farmers it's better to be able to visualize data in the form of the maps. So we are using also map viewer for visualization of recommendation coming from optimization module. So important is to mention the role of MDIS. It helps us to transform data into the internal form of our system, because as I mentioned, we are using different external databases. These databases are in different formats, and to be possible to use this data, we have to provide it transformation of the format into internal format of the system. So with the MDIS, we are able to easily replace one external source of data with other, and to provide mapping of this information into our format and use this external data. So MDIS is, as I mentioned, plays the role of data transforming and help us to integrate heterogeneous data. We expect in the future extended also the data sources from other data, because all this recommendation depends on the amount of quality of the data, and it is important to have as much as data as possible.
To access Coin Portal, just open your favorite web browser and type coin.wirelessinfo.cz. Coin Portal is built on Liferay Portal framework. This framework is mainly used for its complex functionality, including content management system and document library. Access to Portal is secured by password because Portal works with private data of farm. Security is important for farmers to share data. Portal is divided in several parts: content area, for example blog, GIS part, map viewer and geohosting, metadata part, catalog server and client, and coin tools. Content management system of Liferay provides administration of generic informations and also supports collaborative tools like chat, blog, message boards, discussions, rating, localization of content, and Wysiwyg editor for easy editation of content. Map viewer provides access to data from farm and also to reference data like orthophoto, cadastre, topographic maps, and others. Viewer supports interactive work with map like zoom, layer switching, layer querying, but also other operations like opacity, filtering, styling, and other. It is tool for preparing input data and also tool for visualization of analysis outputs. It is based on HS layers, which is extension of open layers developed by Wirelessinfo Living Lab partner HSRS. Geohosting is application used for map publishing and creating map compositions. It allows uploading of another spatial data on portal and publish them in compositions. This makes interaction with advisor and farmer easier. Advisor prepares data for farmer, which farmer will need for work. Geohosting contains two tools, Mapman and Dataman. Dataman is used for management of spatial data. You can use data stored in files or in databases. Dataman takes care of data created using sensors or by data collection in terrain or other methods. It can be also used for importing data from files to databases. Mapman is tool used for publication. Mapman works with map projects which can be very easily set by few parameters like name, keywords, or area of interest. After setting of these parameters, you can just add layers, set style of them, and then you can preview them in map or, for example, in Google Earth. To view this data in Google Earth, you must also provide password. Mapman allows to create map outputs which can be embedded in text or services like WMS or WFS which can be connected directly into Map Viewer. Compositions from geohosting can be added to map to have better view of problem. All data in system are described by metadata which allows easy sharing and selection of correct data by needs of application. Metadata functionality provides help service remote sensing catalog called MITSCA.
Now, let's start with introduction of COIN Tactical Production Planning Tool. Tactical Production Planning Tool was developed by Wirelessinfo in COIN project and it was integrated to COIN Wirelessinfo platform. The core of our Tactical Production Planning module is written in Python and for modeling we are using Python library PULP. The Tactical Production Planning module was designed for solving problems in which we suppose that a farmer has number of fields and he would like to choose optimal product and optimal production method for each of the fields. Now, let's say a few words about relations in the problem. For solving the problem, we need a lot of input data for the model. The input data has to be computed from data from our sources. The data which we are using are data about fields, data about crops, data about external factors, and data about relations, for example, data processing formulas. We also need farmers' preferences. The sources of external data are, for example, the public database of Czech Statistical Office, the Institute of Agricultural Economics and Information, and public database of Eurostat.
MDIS is used for harmonization of data used in this scenario. In this example, we will use data from Czech Statistical Office, mainly prices of agriculture crops. First, we need to export them to XLS. And then transform them to comma separated text, and this is mainly because of possibility to import to database. For import to database we will use PHP myadmin, which takes this data, and after execution data are imported. As you can see, there are 4 columns. One of them is name and 3 others are prices. In MDIS we will need some XML scheme which we will use for harmonization of data. Then we select connection string and query, which will be used for harmonization. As you can see, now we are selecting only 2 columns. After execution of query, data are displayed in table. And now we need only select a node on which we will perform mapping. After mapping, we need to hit change query. Column titles are changed. After performing mapping, we can see data, we apply mapping, and we can download data which can be used in our coin modeler.
The input data for the model are computed from data from our data sources. Then we have the input data for the model, and we put them together with mathematical model. Then we solve the problem and obtain the optimal production plan. Let's briefly demonstrate using of production planning tool. First, we are going to choose data files. We are choosing farm data and external data. Now we have the data ready and we are going to set our preferences. We would like to grow at maximum 3 products from our choice. Because we would like to reduce risk, we will try to diversify our production. Let's suppose that none of the products shall be grown on more than 1/2 of total area of all our fields. Let's suppose that we have some reason for growing winter wheat on more than 1/3 of total area of all our fields. Now the preferences are set, and we will hit Process to pass our preferences and the data to mathematical model and start the optimization process. We are waiting for results. Oh, here they are. Here is the value of expected profit. Here are the selected products, and here is the production plan. In the first column, we can see ID of fields, in the second column, product, and in the third column, method of growing. We can also display the results in map. In production planning, we must deal with the fact that some data has stochastic character. For this reason, the tactical planning module enables using scenarios. The scenarios can differ in selling prices of products, yields, and costs. We will now select the data files with data for scenarios. We will set number of scenarios and using of decision metrics. Now let's hit the process. Okay, let's look to results. Now we can see 3 different production plans for 3 different scenarios. At the end, we can compare the values of profit for each combination of production plan and scenario. This enables the farmers to deal with risk.
Results from modeler are only text-based, but because it's some informations about fields which can have spatial representation, it's not a problem to connect them with some spatial geometry. In the beginning we have empty polygons without any informations, but after execution of modeler, these data are mixed with those polygons. After this process, this data can be colored by some filter. For example, on this picture you can see that if the method is standard, it will be colored red, and in the center of polygon will be placed name of crop. After the optimization process has finished, you can see at the end link to map. If you click it, map window will be opened and you can see data from optimization in the map. On the right side you can see legend of these methods. So now you can see that there are intensive with VRT, and some of them has no methods. If you zoom in enough, you can also see names of the crops which should be on these fields. So for example here, winter wheat, corn or poppy seed.
So, the second part is search for machinery, or we call this sometimes as machinery leasing. As I mentioned in the beginning of my presentation, the big problem of farmers is investment and, for example, harvesting machine or some fertilization machine price could be some hundreds thousand euro. So mainly for small farm, the investment is very big, and if we consider that some machinery is used on some farm only for 1 or 2 weeks, it is not optimal to invest the big money into such type of technology. In principle, there are two ways how to improve the situation. One is use service organization, completely outsource the services to service organization. This model is what we are now using in practice. Other possibility, and this model is used in some countries like Germany, is also to support some exchange of machinery among the farmer, when farmer can offer the services to other farmers. For this type of services, we use SCMS tool, which supports the search of about the machinery, but also service supplier on the base of the products, competencies, services, and documents. We describe now the MGM as service organization, their services and machinery as using the ontology, and this ontology was imported into SCMS, supporting search for machinery and services. So about this type of services, we are able to obtain the information about the properties of machinery, but not only this, but also about the owners, related products, companies, and farmers can select from whom he will hire the machinery for his operation. A tady už to dokecá někdo další.